Today I will show you how to create heli milling program in internal diameter. It is very easy. You are just going to change some variables and let's get started. Also guys, before we start our tutorial, shout out to all my subscribers, especially to Jumel Ignacio and to the person who taught me how to use CNC machine before when I was starting my career in CNC machining. His name is Martin Conrado, and also another guy is Denver Tambalkin. He is also in New Zealand and also Custom Philippines. So we're going to start our helical milling in internal diameter. So go to background edit and device change, CNC memory, and then go to tutorial folder. Open, and we are going to make new program name. We call it heli milling or heli mill ID. Then create, then open. And guys, since I have my registered fix form, go to fix form and program start, insert. So again, I have this all cancellation, and this is G codes and M codes. And then we go to fix form again and select the tool start, insert, and we are going to change our tool number. So our tool number is tool 23. So we put this one N23, tool 23, H23, D23, and we are going to compute our spindle speed. So we use 200 meters per minute times 1000, so 200,000 divide 3.14 and divide 63, which is the size of our tool. So our spindle speed is 1000. So we put 1000, and now we are going to our fix form again, and we are going to select our heli mill ID number 1, insert, and again before we forgot, we select number heli mill number 2, insert again. This is the continuation of heli mill number 1 because on there is no enough space on the fix form. That's why we need to make another one. And we go to fix form again. We end our tool end. So we have this one, and put M30 because that's the end of our program. And then we are going to alter some of the information needed. So let's say you are going to G1 G90 sets plus 2 feed 5000, and now we're going to compute our feed rate. So our spindle speed is 1000. So we are going to use 0.15 per tooth, and we have 5 insert. So 0.15 times 5, so 0.75 times 1000. The same formula guys. So our feed is 750, and then at the bottom we have another feed. So this one is canceling our G41. This one is going back to to X0, and we can make this one faster. Let's say 2000. And now we are going to change our diameter. So this variable number 4, guys, is the diameter of the bore you are going to do. So let's say that one is 200. So after changing your diameter, nothing else to be changed, and we have now our program. So guys, if you are going to change your diameter of the bore, this is the only one you are going to change. Let's say you want 150, so that's the only thing you are going to alter. If you have the same depth, but if the depth of your bore is, let's say, minus 50, so you can just alter that one. And it depends upon to you guys also how much depth of cut do you want. Let's say if you want 5 mil, so you can change that one to 5. Then every helical movement of your tool will be 5 mil, but it depends also on your machine's capability. And also make sure you have your spindle speed and feeds on the right amount, so that you are not going to break your cutter or your insert. So guys, let's see if this one will work later on after my machine finish this operation. So I will show you if our program is working the way we want. Let's find out if our program is going to work the way we want. So now go to simulation and start. So looks, guys, it is working the way we want. Right. We can try using single block so that we can see it one by one. So positioning 2 mil above the job, and reads that G41. So now it's going to rotate 5 mil every revolution, 30, 35, 40, 45, and 50. So that's the maximum depth we set. Minus 50. So this one, guys, minus 50, and our depth of cut for each revolution, complete revolution, is 5 mil. Also, guys, if you want to make it 2 mil, you can do it. And minus 10, and we try it again. Single block, okay, it's every rotation is 2 mil up to minus 10. And let's try another one. So let's say you have the idea that you're going to machine is below your Z0. So let's say minus 50 below your Z0, so minus 50, and we can make this one minus 52, and we make this one, let's say 100, minus 100, and we change our diameter to 200. And let's see again on simulation. single block. It's reading all the G codes and M codes. So it went right away to minus 50. Cuts the your material. So minus 52, 56. But so guys, the one you are actually seeing is just the X and Z, but in actual world, if this one is cutting, not in simulation, you can see the X and Y and Z are moving at the same time. So it will stop to 100 hopefully. So guys, you can see my program is working the way we want. So you can try this one in your machine and let your boss to see it, and I'm very sure he will be happy because you are going to make your program less time and easy. So that's the way how you do it. Put it back to 50 again. So guys, thank you for watching this video, and thank you guys for tuning in to our tutorial, milling of internal diameter. And if you are happy guys, please consider subscribing to our channel, give us a thumbs up, and also please leave a comment down below that you subscribe. I will try my best to reply to you as soon as I can. And also please don't forget to click that bell notification button so that you're always get notified when I upload my next tutorial video. And see you next time. Keep safe guys. And of course, my one and only Donabels, thank you so much for believing and pushing me to YouTube, because before I don't want to be in YouTube. I thought I don't have the courage, I don't have the ability to do video like this to be seen in public. And also big shout out to my family, Ate Dipol, and to all my pamangkin that always supporting my premiere, always watching.